In this course, you will not only learn the basic calculus techniques such as limit, differentiation, and integration, but also you will learn Taylor series expansion and Fourier analysis. All of these will be done in 2 hours. Here is how we will do it. First, let's have some understanding about calculus on a high level. Calculus is a complex toolbox with layers of tools supporting each other. Calculus 1 focuses on differentiation and integration. They are the core tools calculus develops, but they are more means rather than ends. Eventually, they are used to power the ultimate tools that we can use in our real life. Tools that can help us understand, analyze, construct relationships, and eventually find relationships. So differentiation and integration, they are at the heart of calculus, but they are not standalone. They are based on the limit tool, which is based on the more fundamental math tools, algebra and geometry. Because calculus has so many intertwining layers of tools, it's usually a difficult topic. Traditional school teaching starts from the inside going out. You approach them sequentially, but learning this way, it's hard to see the connections among them. Without seeing the connections, your brain will be under a lot of stress, because each topic is difficult in itself. So it's hard to understand and even harder to retain the knowledge. It's like puzzles without grooves. They will only fall apart later. So in this course, we will not proceed in the typical sequence. We will be jumping between these topics to understand their connections. In a typical trigonometry course, most people learn a few special signs and lots of complicated trig formulas. But in my opinion, what really should be taught is this powerful sine formula. It tells you a direct relationship between the values of sine and the angle. It allows you to compute sine for any angle. So our goal is to build this formula from scratch. We want to know the relationship between sine and the angle. The Taylor series expansion of sine is saying sine theta can be understood as the initial sine plus the change. But sine changes with the angle. How much sine changes depends on how fast sine changes with the angle. So the velocity of change, v, and the angle change, which is the theta. Because sine 0 is 0, sine theta is just the velocity times the angle. This is what this first term is about. The reason there are all these extra terms is because the velocity is not constant, it's also changing. So we need to figure out the change in velocity. That leads to differentiation. Then we need to figure out how this velocity impacts the overall sine. This leads to integration. Because the change is changing all the time, this leads to the concept of limit, which is built upon algebra and geometry. Combining all these together, we will construct a Taylor series expansion that can compute sine for any angle. After you know how sine is computed, we will show how they are used to solve real-life problems. We will explain how it's used in sound analysis, particularly Fourier analysis. Here is the content structure. We will first do some introductory lectures giving you an overview of the Taylor series method. Without using differentiation, we will see what those velocities should be based on intuition and geometry. Then we will talk about how integration technique is used to accumulate the impacts from those velocities. Then we will talk about the differentiation technique that can get us the velocities precisely. Then we will put things together to build the Taylor series expansion for sine. We will implement it using Excel. In the end, we will use a simple example to demonstrate how sine can be used to analyze sound signal. We will first talk about what is Fourier analysis, and then why it works, and lastly, how to run Fourier analysis. You don't need much background to follow this course. We understand how painful it can be to learn calculus without knowing the end application. So please join in this course if you want to learn calculus in a brand new way. The course link and coupon is attached in the following description area. Your support will encourage us keep making great content. Thank you and happy learning.